taken without proof. The first one that I'm going to write is velocity. And velocity is just a ratio. I'm going to say velocity can be represented with v. It's a vector as well. So that means it has magnitude and direction. And velocity, let's just say velocity in the x direction is going to equal to x final minus x initial over time final minus time initial. All right. So one is spatial displacement or linear displacement, not spatial, but linear displacement. And then the one on the bottom is temporal displacement. So we have our time change and we have our linear change. That's an x. Yep. It really means velocity in the x direction. That's what I'm trying to say. All right, so that's number one, equation number one. All right, I just wanted to kind of put that there so you guys will know that's what I mean. So equation two is going to look like velocity in the x direction. And let me make this clear as well. These are averages. And I don't want to write average for each one of them, but in this particular case, we're looking at the averages. In fact, we're always looking at the average. So I'm going to go ahead and say the initial velocity in the x direction. So again, I'm using that little knot there, plus the final velocity in the x direction divided by 2. That is our statistical representation for velocity. No. You're talking about as far as the average goes? Maybe. Oh, this is an average. So we are just taking the two velocities, like the first one and the last one, we add them together and divide them by 2. That's what I mean right there. Mm-hmm. And then we have 3. Acceleration in the x direction. That's going to be the change in velocity in the x direction over the change in time that it takes that velocity to change.